And the common log to us, that means log base 10. We just don't write the base. So if I walk in, I said, what is the log of 426?
2.62.
Yep. You go to your calculator, depends what kind of a calculator you have there. Some of them you have to write the number first, some you have to write the log first. On this one, I write the log first. The log, what is it? Of 426. Push enter or equals 2.62941. It should be one big button.
Inlog, I see inlog.
Can I see, just tell you, no, let me see your calculator there.
It says inlog right there,
Yeah, that's probably it.
That's the natural log, okay.
but it's not.
And you hit it, oh, if you hit it again, it becomes the log.
Oh, hit it twice,
Yep.
not just second, but just hit it
Nope,
twice?
just hit twice, yeah, it goes.
Perfect.
Well, actually, this, you know what? Yours will do any base.
Oh,
Wow.
I like that.
So you hit it once, it goes to the natural log, you hit it again, becomes the log base 10, you hit it again, the log to any base. You can put the base,
Okay.
I can put base 3,
She knew her answers.
then go to the number, and 27 should be 3. Yep.
Okay,
Wow.
great.
So this will
Thank
do
you.
all of them, yep. I wish I didn't tell you that. Because that's part of my lecture today. It's going to take the fun out of my lecture. Some of it.
You can get the Mouthway app on your phone. It'll do that.
Now, just a quick reminder. The graph of the log looks like this. This is the 1, and the value for that is 0. So if we go to our calculator here, and we ask for the log of 1. From this picture, the answer should be what? 0. Let's see if it gives us that. Log of 1. 0. If we ask for the log of negative 3, it should give me an error.
Can't take.
Yeah, domain error.
Right? Look at the picture here. Your domain is what? X has to be greater than 0. You can't pick a negative number or 0 there. That's what the graph is telling me. So if I go to that graph and I go, okay, the log of negative 3,
Domain error.
domain error, because you can't take the log of a negative number. Error. If I try the log of 0, that's also error. The number has to be greater than 0. That's rule number 1. You can't take the log of a negative number or 0. That's an error, but you can look at the calculator to verify that. If I take the log of 0.5, now before you hit the button on your calculator, look at the graph here. The log here is the y value. This is the 0.5, somewhere here. So do you think your answer should be positive or negative? Negative. It's below the axis. So the log of 0.5, negative 0.3. So if the number is less than 1, any number less than 1, between 0 and 1, when you take the log of it, the answer is going to be negative. Any number larger than 1, when you take the log of it, that's the y value, the answer should be what? Positive. So the answer to the log could be negative, could be positive. If x is less than 1, the answer is negative. If x is more than 1, the answer is positive. So because I told you before, you can't take the log of a negative number, but don't be surprised if the answer to the log is a negative number. For example, what's the log of 0.0005? Negative 3 point something.
3.30.
Negative 3.3. Because that number is close down there, the y value. So the answer of the log can be negative. If I said, what's the log of 22? 22 is more than 1. Should be what? A positive number.
No, very small.
Oh, log of 22. I did 2 here. 1.34. So your answer could be negative, could be positive 2. So if you give me a number, I can tell you what the log. On my calculator, I have a button that says log. It will give me the answer to any log as long as the base is 10. I can also work it backward. I can give you the answers and tell me what the number is. Here we go. Log x, I'm going to use Amanda x here instead of y, equals 0.2. What is x? Well, remember what the second or the third property is of the log. You can take a log and change it to exponential form. So if you look at that, x will be what? The number will be the base raised to the answer. What's the base here? The base is 10. What's the answer? 0.2. So if you go to your calculator, it's amazing where you see that button right over the log. You see that 10 to the x? On my calculator, right over the log, it's called the inverse.
Oh, yeah.
So since it's over, I have to hit the second key. You can actually write 10 to the power directly if you don't want to do that.
Yeah, that's all I
You can go 10 to the power of 0.2. 1.585. But if you did the second log, it does put 10 to the power for you automatically, because the machine knows what that is, the inverse. So if you know the answer and you're looking for the number, we hit the second log, which is 10 to the power. So it does the 10 for you, puts the power, opens the parentheses, you just write the 0.2 there. So it saves me some time.
Say again what you do there. You hit the log button?
Nope.
No.
Log y equals negative 0.3. Let's look at that. So on my calculator, that says the base is 10. Y will have to be the base, which is what? 10 to the power of negative 0.3. So I'm going to go to my calculator there. I'm not going to write 10 to the power. I'm going to have the machine do that for me. Second log.
It's like 0.5.
When I did the second log, you get 10 to the power, right? They already typed that for me. So all I got to type now, negative 0.3. Close the parentheses. Hit enter or equal 0.501. I mean, you can type yourself 10 to the minus 3. I'm just trying to take the easy way out. Log m equals negative 2.4. M is going to be what? 10 to the power negative 2.4. So let's go, here we go, to my calculator. I don't want to write 10 to the power, I'm lazy. Second log, it does that for me automatically. 10 to the power. Let's go write negative 2, that point, negative 2.4. And I came up with 0.00398.
Yeah, I got it. You see that note, that 03, that means you moved the decimal.
Yep,
Scientific
you're in scientific notation. Yep.
Because I do that all the time. And oh, I see.
I know what you're asking.
I didn't guess what I.
How about this?
And then,
I'll put in that answer.
you see the 10? Shift 10 and then 0.3.
N will be what?
Or just that.
10 to the power of what? 10.5. I'm forcing my calculator to be in scientific notation now.
Yeah, because the number's going to be so long.
I made it big enough.
Oh,
And notice that's what you got. You were asking, you have some crazy number. It looks like 3.162 times 10 to the power of 10. So when the number is big or small, most calculators will put in scientific notation. That's what that number is called, scientific notation. So if we're asking you for the log, just hit the log button. If we're giving you the answer, we're looking for the number, that's where the second key comes in. This is the whole lecture for this section. Let's take some problems from the end of the chapter. Practice with them. That's section 4, 13.4. Let's find this. The log. You try it. Of 9.24 times 10 to the power of 6. What is it?
Overflow error.
No. 6.1.
6.9.
Oh, 965. Let's say 6.965. Well, let's see. When you write that number, intentionally I gave you that number. You hit the log, and I gotta write that number.
Oops. Well, that explains why I did that.
Ready? When you write that number, it's 9.24, not times. Don't hit times. On your calculator now, look for EE or EXP. EE, or that's a key there, or EXP. It might be in yellow or blue over the keys.
What about EX? Wait.
EXP,
No, just E to the X.
not E to the X, no.
That's natural.
Yep.
Right down here. Function key, and then like, oh, found it.
So you're going to hit that key,
And then 6.
then you write 6. So you hit that key, and you write 6.
What's that E?
That's exponent. That means 10 to the power.
Yeah.
Oh, so that it just sets it to 10?
Yeah, when you see that, that means 9.24 times 10 to the power of 6.
Or you can just do 10.
So now you hit equals,
No, is it not?
and it's 6.96567. A lot of people want to hit 10 times 10 to the power. So if you do that, if you did the log of 9.24 times 10 to the power of 6,
That actually works.
Mine works.
it should work. But what you did there actually, the way this machine treated now, treated as two different problems. Because it looks at this as a multiplication. And the rule for multiplication says when you have multiplication, break it down to 9.24 plus the log of 10 to the 6.
But it does it for you, right?
Yep, it does it all. But that's what the calculator does actually. It breaks it down to two problems. So the answer to this is 6. Then it finds the answer to that. Which is 0.96567. When you add the two numbers at the end is what? So that's really what the calculator does. When you write it the other way, it treats it as one number. It doesn't have to break it down. When you write it times, then the calculator will break it down and do the calculation on it.
Because you like 10. Because you like 10. No.
Nope.
Ask him.
No, don't put 8 and 10 to the power. If you put e in 10 to the power, that's wrong.
That's wrong.
Yeah, that'll be wrong, yep.
So what do you put? Just 6?
10 to the power, not e,
Oh.
that little caret. Yep.
I'm getting 3.5. Do log 9.24, and then what do you put in after
Yeah,
that?
just
EE.
put XP or
Oh, wait,
EE.
9.24 and then what?
EE or EXP. Which key do you have?
Do you have the double E key or the EXP key?
It's on the bottom of your calculator, probably.
Hers is way different than mine.
And you write 6, not 10 to the 6. So you put EE or EXP and you put 6, not 10 to the 6. That EE is equivalent to the 10 to the power. So when the calculator sees that, it knows that's 10 to the power. Let's try another one. Let me do stuff where you might not actually use it on that. The log of cosine 12.5 degrees.
So we're gonna be in degrees.
That means you got to be in degree mode. Exactly. Check your calculator, make sure you're in degree mode. Where's my calculator? Here's my degree. And I need to be in degree, DEG. On mine, I can move it till I get in degree mode.
Yeah, I could put 0 and 3.
Then I go the log, parentheses, cosine, parentheses, 12.5, close the cosine, close the log. Negative,
Do you have to close the press? Yes.
yes,
That's hard.
Or it-
twice.
Wait, 12.5?
You gotta close it twice.
You don't have to type in degrees.
You gotta close the 12.5, then you gotta close the other one.
Gotcha.
It's okay, I don't know how to do that on this calculator.
Make sure you're in degree mode,
These- I love these calculators, they're so easy to use.
if you know how to use them.
Yeah, I do.
So,
Most of the time.
Millions, is it working on you? Can you show her? Okay. Okay, let's do this one. The log of the square root of 214. By the way, if you don't have a calculator, you have your laptop. There's a calculator on the laptop, scientific one too. I don't know about the Mac, but I know it has one, but I know on the other one you go on Windows and accessories. So to write this one, I can write the whole thing in one shot. Here's the log. Then the square root. Where's the square root on this?
Yeah, that was right. I did make the
On the left,
No, this is different. Okay, square root. I'm going to write the 214, but notice the square root has a parentheses in the front. So I got to close the parentheses for the square root. I got to close the parentheses for the log.
and there you go.
So double closing parentheses, one for the square root and one for the log. Hit equal 1.16521
yours doesn't go up very far.
because I set up to just give me 5 decimal places
Oh,
because there's a setting on it.
don't do that.
Yep.
Sometimes they want like 5.
well, I know, but it just, it's cool enough.
I can set it 1, 2, 3, 4. Yep, you can set how many decimal places.
Is a video that.
Let's have you try one or two more. Then this section is done.
Oh,
Log of x equals 0.929. Notice again here. What did I give you? I gave you the answer. I'm looking for the number.
Yeah. Based on
So that's the inverse. 10 to the power 0.929. We're not looking for the log of 0.929. I'm giving you the answer. I'm looking for the number. The other ones, I gave you the number and I was looking for the answer. That's why it was the log button. Here backward, I'm giving you this. I want that number. I'm giving you this. I want that number. So 10 to the power 0.929. 8.49, right? Log z equals,
now Professor, why, when you type in log exp 0.929, why does that not give you the answer? Can you say you just do that instead of 10?
log what? No,
You type in log,
no log. No, it's just 10 to the power, not log 10.
oh,
There's no more log there. So this one here, it becomes z equals what? 10 to the power. There's no more log when you switch it to this. That'll be a very small number.
Yes, barely exists.
10 to the power of negative 6.9.
0.000000012.
Here's the problem with my calculator, because I set it to five decimal places. See what it does? That's the problem with it. So you want to carry more decimal places.
5, 2, yeah. 1, 1, 3.
You, yeah, you can't even
It's
do
a
that.
2.
1-3.
Yeah.
So if you tell the machine, give me the answer to 5 decimal places, cute. But when you're dealing with a problem like this, then you're in trouble. Log m equals
Wait, is there six?
negative 1.3. M equals what? 10 to the power of negative 1.3.
No, but it says 7. Oh, 7. So you're missing one.
0.050, and there's more numbers, but I give up here.